Well, hello everyone. Welcome to another Toolbox Tech Talk this Sunday, 2 o'clock Melbourne time. And we've been having some technical fun just leading up to this session, so it might be a bit of a scratchy start. But before I get into it and introduce my guests for today, I just want to reach out and say thanks to everyone who attended my last Toolbox Tech Talk. It was the biggest one ever. Amazing how just saying the words cryptocurrency gets everyone excited. This year is going to be a bit different with Toolbox Tech Talk. It's basically talking to the solar industry, but with lots of kind of side issues. So we've already looked at using surplus solar energy for mining cryptocurrencies. Today we're going to be talking about EVs and the relationship with renewables and all things to do with EVs. But I've got some exciting guests coming up for the rest of the month, so I'll probably send you out a little promo for those. But just wanted to let you know that I do run training courses here at the Smart Energy Lab online. I've got a course coming up next week. In fact, it's just a 3-day, half a day each day, Tuesday, Wednesday, Thursday on the solar and battery standards. So it's kind of like an advanced course for those who are already involved in the industry, who want to really be good at compliance. The following week, I've got a 5-day, it's 5 half days, it's via Zoom meeting, solar and battery system installation and design. So it's really aimed at taking you from go to woe, or woe to go? Woe to go, that's probably better. All the principles around sizing a battery and solar storage system, whether it's on-grid or off-grid. So that's quite a big course. It's, basically 4 hours a day for 5 days. And those are all online. You can find them and enroll through my website, solarequip.com. You'll find the training link there and you can go and enroll. But anyway, look, today we are very lucky to have an expert on electric vehicles. And so my guest today has been working and writing on electric vehicles since 2008. So really a lot of experience in this area. His interest in EVs came from a desire to lead a low environmental impact life. And his current drive is the Hyundai Kona Electric. Yay, I've got one of those too. So thanks. And it's my great pleasure to introduce Bryce. Now let's see how we go here, Bryce. Give me that elevator pitch again, why you'd choose an electric vehicle.
I'd say because they're so much smoother, cleaner, easier to drive, far quicker actually off the mark, and they're faster and more powerful than an ordinary standard car, especially with the standards that are coming out in Europe and what have you, where they're putting little turbocharged motors and what have you in them. So there's all those sort of laggy issues. You don't have it's single speed reduction gear, so you put your foot down, instant acceleration, smooth all the way up, no gear changing, whatever. And the fuel costs are way cheaper, as well as there's no more service in terms of the timing belts and all those sort of things are long gone in terms of electric vehicles. You don't need those. So my Kona, for instance, is $165 for 15,000 Ks or annually. And for that, I get a map update. I get basically a safety check all around. All the service updates and the recalls get done. So $165 a year, I'm pretty happy.
I had the same experience. I said, what's the service fee for? They said, we update your GPS. And I go, yeah, right. Okay, so that's going to take a lot of work.
Yeah, they do all the safety checks. They check the brakes, they check the tyres, they check the tyre pressures. They lubricate all your squeaky door locks or whatever. It's just a walk around the car, and it's nice to have a second set of eyes going over it. So I don't mind paying that for a safety check and the map update, as well as any service recalls. Like they recently did a battery management system recall because they had about 13 or so cars all around the world. Konas catch a light due to fully charging, occasionally being left plugged in. So they changed the battery management algorithms, and they're doing another one on the brakes now at the moment. So I must admit, I'm quite happy that they said, we've got problems or issues with it, bring it in and we'll fix it. And just plug it in. But in some ways, like a Tesla, except it's not over-the-air updates. You have to drive in and they plug it in and do it. But cars are now mobile computers rather than vehicles anymore in some ways.
Well, look, we've got our first question from the audience, and what do you know? It was the last thing I put on my list for today, but we'll jump straight into it. We don't actually have to go in any order. So David asks, is the government considering charging tax per kilometre travelled to make up for fuel excise, or just upping the cost per kilowatt hour for EV charging?
Well, I wouldn't be able to up the cost per kilowatt hour of EV charging because you plug into a power point. If you wanted to avoid the excise, you could just plug into a power point if they went that way. So that wouldn't be possible. They're trying to do a per kilometre charge or an annual fee type charge on just EVs, which is pretty stupid. It's a bit like taxing non-smokers for not paying the excise on tobacco, for all the health damaging effects of tobacco, and putting their own money into that and going, it seems pretty dumb to me to be actually at this very early stage of the EV adoption curve in Australia to be trying to put taxes to effectively discourage. They're only maybe a couple of $100 a year. It doesn't work out to a great deal, but it's more the principle of the matter. It sort of shows the government's not really serious about EVs. The weirdest part is,
have they actually announced how they're going to what the fee is?
The per kilometre, and I think it was about 4 cents a kilometre or something. I'm not quite sure of the exact numbers off the top of my head, but it worked out to a couple of $100 a year for 10,000 k's.
So that would mean you'd have to have like trucks do something on your wheel that measures your distance travelled.
No, they'd probably do it either in New South Wales. It'd be easy because they do an annual green slip, but the states have announced it. South Australia tried it. It was pretty much held down and they dropped it just as quickly. New South Wales floated the idea and quickly scuttled it. Victoria's the only one that's floated it, and we're trying to throw a few cannon shots at it at the moment. With any luck, they may be wise up that discouraging an uptake of a green, clean vehicle is pretty dumb.
So it's not a fait accompli. That's good to know. So we should put some pressure on our local state members, pointing out that I love that analogy. It's like taxing non-smokers for the health damages that smoking gives.
We're not putting in for ameliorating the health damages to all the smokers going.
Yep.
And putting people off. We have 0.059 new car sales are EVs. So you round it up to 0.06. It's just, or 0.6, I should say, 0.06. 0.6, I think. It's ridiculous to go.
We've got another comment here, which is a good point. So plug-in hybrid vehicles, do they pay twice when running on petrol under this proposal?
Well, if they're running on petrol, they're saving when they're running on petrol, not running on electric. So you wouldn't be using electricity when you're running on petrol.
Yeah, but it's a hybrid. So do you get taxed for the amount of electrical energy that you're using, or is it only for pure EVs?
It's only for plug-ins. So if you're putting energy into the battery and driving off the battery, then you're using that energy in the battery. So you'd be paying for that per kilowatt hour or whatever, per kilometre. Oh, yes, per kilometre, yes. It would be an interesting one. I was thinking back to the question when I said per kilowatt hour and got muddled. Apologies there. No, it would be per kilometre. That's a very good question. I think they're talking pure EVs.
Yeah, let's try and make it as difficult for them as possible with all the kind of curious arrangements. Like, what about if I take a petrol generator and put it in the boot of my car and charge my car with that? Then do I have to pay the excise?
And I like the fact that it's only being put about by states, which, given the fuel excise is federal, why are the states even doing this when they're the ones encouraging green energy and especially South Australia reach 50% plus renewable sources? Why are they talking about taking the fuel excise back from the federal government and putting it in the states? It's just, it doesn't make sense. There's some political game going on. I don't know what it is.
Oh well, we'll fight the good fight and try and stop it. Coming back to my questions, so look, tell me a little bit about your history of EVs. You've had a few of them, right?
Oh yeah, my Kona is the fourth EV that I've owned. So my first one was I picked up a second-hand ACT blade converted Hyundai Getz. That was in about 2012. Before that, I was actually building conversions back at started at Ceres Environment Education Park in Brunswick about 2008. So I've been working with EVs since then. And then when I went to a TAFE, whose name was Swinburne, their name escaped me for a moment. We were doing sporting series with their EV conversions. And then I actually ended up working at Ceres for several years doing EV conversions there. And then we set up our own business. And then around 2012, in the great sort of disappointment of no EVs really happening, people lost interest. People weren't prepared to pay $60,000 to have a car converted, which, by the way, is still roughly what it would cost to convert a car now if you're paying someone to do it.
Wow. It makes buying a new one look very reasonable.
Yes. So these days it's a lot cheaper, unless you're trying to convert a classic car or something of interest that you wouldn't have normally. You would just go out and buy a second-hand EV or even a new EV. My Kona would be cheaper than the conversions we would have been charging for. Yep.
Wow. So you've had four. So you've built some of your own. What commercial EVs have you had?
The first one was the Blade Getz. The second one was a Nissan Leaf, one of the first generation Nissan Leafs. 2011 model. And then the third one was actually one of the cars we converted. So it was a Citroen Berlingo van, and we did that one in 2011. And that one was still going in 2017. I bought that one as they retired from business. I bought that back off them and drove it around for several years before buying the Kona. And then I've sold the Berlingo to someone who's actually starting up a business in doing specialist or classic car EV conversion. So they're learning from that one and starting to build EV conversions, VW Beetles, those types of things.
Now, I know that you and I are part of the Kona fan club because we both own one, but I mean, of course, there are other EVs out there. But the Kona Electric was it win Car of the Year or something last year? It was.
It's won a lot of different. It's supposed to be first of the reasonably affordable EVs for the mass market. So it ticks all the boxes. I mean, my heart said I wanted a Tesla Model 3, and I was one of the people who lined up on the first day when they released the deposits for them, except that as they slowly released all the specifications for it, it's less and less fitted the sort of things I wanted out of a car. So it was a sedan, so it had a small boot. It was actually quite a large car, not a small one that they advertised. I don't like the dashboard that they have in them. It's just a personal preference. I know a lot of people love that central dashboard. It's just something I just couldn't get to live with. So I basically sat down with all my criteria and looked at all the different EVs that were available or coming available. And the Kona wasn't there yet available, but it was overseas. And the Kona, my head said, was absolutely perfect for what I wanted. A nice big hatch, rear seats folded flat, had a good range and DC fast charge, which I would have loved a Renault Zoe, but it didn't have DC fast charge. So I ticked all the boxes, so my head ruled over my heart. Bought the Kona, and for what I use it for, it is brilliant. I mean, I've travelled interstate as far as northern New South Wales. I've gone inland. I mean, I drove back from Coffs Harbour to Melbourne inland via Dubbo and Tamworth, or Tamworth and Dubbo, and it took me 2 days. So it was no slower than we would with a petrol car. The same sort of trip I could do Sydney in a day. Again, with the fast charge networks now, it's even only a skeleton of a network. It still gets you around, pretty much all around New South Wales. Many thanks to the NRMA for putting out in those new DC 50 kilowatt chargers, for instance.
Right. Well, since you mentioned chargers, that was actually one of my questions coming up too, which look, I must admit I was a bit confused by all the options early on when I was looking at EVs. Names like CCS, CHAdeMO, Type 2, Type 1, DC charging, AC charging. And I know you've done an excellent series on this for the Australian EV Association. I watched your webinar on it. It was really good. But in a nutshell, are we moving towards some standards in terms of ways of connecting charging sources, or they're actually supply sources?
As I said, the EV charging war is over. The EV charging speed advertising, the advertised EV charging speed war is only beginning. So the EV charging plugs are settled on for DC. Actually, whilst I'm babbling away, I'll see if I can pull up a slide to show you the different types of chargers around. But the DC standard is pretty much settled on what's called CCS, or Combined Charging System. And everybody except Nissan and Mitsubishi use that one. And Nissan are giving that one up with the Ariya, or Ariya, I can't remember how you pronounce it, but it's the next one that's coming out. It's going to CCS outside of Japan and America as well. And that's for the DC charging. And for AC charging, Type 2, there's Type 1 and Type 2. Type 1 is a single-phase system that was good for the early batteries that were fairly small. And that was basically because Japan and America predominated, and they have a very low 110, 120 volt system. They don't have three-phase, so a single phase was all that was of use. And they have a two-phase system for 240 volts, so they could charge via that as well. So a three-phase system was of no use. But when EVs hit Europe and other basically,
Oh, we've got a little bit of a freeze on there. I'll just, while we're getting Bryce back from his frozen moment, I've got a question here from Bradley. What is the long-term effect of fast charging on service life? Now, Bradley's a bit of a battery expert, so he's very aware of the effects of charging lithium-ion batteries in terms of speed and voltage, etc. My advice would come from actually reading the service manual, or the owner's manual for Kona, which the Honda Kona, which says that DC fast charging you shouldn't use as your permanent charging source. It's really just a way of bringing a rapid charge onto the vehicle. Oh, we got you back.
Yes, I just did a reload. It was just I was frozen. It's quite warm in Melbourne today, so I'm not quite sure why I froze. As far as I know, for cars that have active cooling systems, which is pretty much everything except Nissan, the long-term effect of fast charging is negligible as far as we know. So various Teslas, for instance, have done upwards of 500,000 kilometres on a battery, and they've lost probably 1 or 2% a year. So it's even an age-related thing rather than a fast charge-related thing. Even the early Nissan Leafs in Europe that were taxis that were being fast charged quite a lot, there didn't seem to be any additional degradation. But the main issue is they're all the ones with the active cooling systems. And Nissan didn't use an active cooling system. They've used a sort of passive, just airflow through the batteries, and they did have significant issues in hot climates with long-term effects on the service life. But the other question I often get is the fact that EV batteries don't die at the end of their service life, so to speak, in an electric car. They say 8 to 10 years in an electric car, but by that time you'll still have 70% roughly of your range left. So in a Kona, if you're beetling around town at 500k range, 70% of that you've lost. You've still got 350, so you probably may not even notice the loss. The other side of that coin is that they then can go into what's called a storage system, as you would be involved with quite a lot. Those batteries have a much gentler life there, and they'll last over their service life will be 20, 25 years all up from new in the car to they finally get recycled.
So you're saying a second life. So once the service life of the battery is expired, it can be put into a different product?
Yes. And Renault have actually started setting up large multi-megawatt battery systems in Europe. One of their factories is one of them, and a number of others in England, where they just plug the battery, they basically use a forklift, stack up the batteries in the system, and they just plug in, and they're a grid backup or a support to their factory system. And in fact, that's what Renault have done with the batteries for the Renault Zoes. They've built some extra batteries for them so they can provide them, if they have any warranty claims, build their new battery at some stage. And they sit in this system, and they're being gently cycled, so they're sort of carefully looked after. So they can pull those out to the new batteries that will be perfectly good for you to use. They'll be looked after. And any other batteries that they've pulled out of other cars at the end of their service life go in there, and they're perfectly good for a storage system.
I have been asked in the past, how practical is it for someone to use, say, a second life battery and just build their own storage system out of it? How practical is that?
You would know the difficulties in building battery storage systems and connecting them to houses and meeting the standards. So it's exactly the same issue. That they're just cells put together with a battery management system and an inverter, but you've got the same problems as a home or any sort of packaged battery system.
Yeah, and I imagine the BMS is specific to the vehicle controls, so you'd have some issues with battery voltage being different from your inverter, input voltages, etc.
Yes, so for the big manufacturers, they build their system to suit, and they can afford to have transformers and electronic systems and rectifier systems built that will just boost up the voltage, whatever they want. Whereas for the home builder, it's a lot easier to pull all the cells out of those battery systems, the car batteries, and rebuild them as a storage system like you would any other set of cells. Anything from lead acid up, it's the same deal.
Now, some of the naysayers about EV saying, well, actually, it's not good for the environment because we're going to be using lots of dirty electricity to charge our vehicles, and we'd be better off just using, fossil fuels. What do you say to that?
Pardon my laughter there. I was thinking the sort of thing I'd hear from Donald Trump. First of all, unlike fossil fuels, you're stuck with using fossil fuels. There's nothing you can do to reduce your reliance on the fossil fuels. As soon as you move to electric, you can, by your own choice, move to more and more green sources or renewable sources. In South Australia, for instance, you're running on about 50% renewable energy already. Second point on that is, even in Victoria, where you're running on the grid, running around town, you are still 5 or 6%, more than that, about 7 or 8%, 10% better off even running on our dirty grid, not running on solar panels or anything else. The only difference if I can find the slide, I might even try done, mind you, to the government's own carbon accounting standards. Here it is. Can I do a share screen and pop that one up somewhere?
Yeah, within the There should be a share
Oh, here
screen
we are.
button. Yep.
Now let me see if I can find it. There it is. Here we go.
Just a reminder, everyone, feel free to, oops, I'll pop you in the corner there. Feel free to ask some questions, make some comments.
Can everyone see that screen?
It's all good. Yep, we can see you perfectly.
Yes, I'll full screen it so people can see it a little bit more easily. If you look at that, if you drive a 2017 Corolla, I haven't updated this for a couple of years. I'm waiting for the new tables to come out. That, by the way, I put out by the government, federal government department for the carbon emissions or carbon CO2e. So it's a full accounting for all of this greenhouse gases. And for a 2017 Corolla, 10,000 kilometres a year, you'll put out roughly 2 tonnes on a city cycle. All around Australia, even on an EV run just straight on the grid in that state, you will do better. So Victoria, you do 1.64 tonnes, so about 1 2/3. In Tasmania, 1/4 of a tonne. And then if you start adding green power or your own solar panels and charging up off them, you're just getting better and better. So I've stopped sharing.
Oh, that was really good, actually. Maybe next time just leave it there for a little bit longer because there was quite a lot of great data on there. I was just scanning it myself, so I didn't quite get to see it all. But yeah, pop it back up again, please. That's a very valuable graph because there's always those naysayers who use some piece of historical fact, but it's totally irrelevant, in current circumstances. Like the one I hear occasionally is, solar panels are not green because they'll never produce as much energy as it took to make them. I mean, that was true probably in 1956. It's not true anymore, but that still persists. It's amazing how those myths can hang around for so long. So yeah, thanks for making it bigger. That's much better. I can see it now. So on the right-hand side, we've got the Corolla using around about 2 tonnes on a city cycle, and combined cycle, I presume that means a bit of country driving and city driving. Yeah.
That's your full sort of, when they do the comparisons for all of the driving, so if you replace it with all your kilometres, like I have, pretty much my Kona replaces everything.
Right. So someone here called Nobody Famous says ChargePoint have 100% renewable sourcing of power. So is ChargePoint a charging service? I'm not quite sure who that is.
ChargePoint don't exist here anymore, but ChargeFox do. So maybe they've just typed in the wrong name. So ChargeFox, yes, they do 100% renewable energy. So you can reduce all those things to zero in the coloured bars.
Right.
Except for whatever it takes to build all their equipment, what have you, and the payback, the embodied energy and all those things. So there's a little bit, but it's certainly way, way better. So yes, the whole point of electric vehicles is you're now freed from the dependence and tied to fossil fuel. You may move as far as you like down the renewable energy.
Imagine you lived in Victoria. That wouldn't be too hard for us. And with the dirtiest grid in Australia, and you're potentially using up to 1.6 tonnes or emitting up at 1.6 tonnes of CO2 equivalent, but you do have choices. Even if you're connected to the grid, you can still produce your own clean energy, right?
Yes, which I do. I have my own solar system here.
So I guess it comes down to how practical is it to produce as much renewables as a vehicle might need in, for instance, a city application?
In my case, my very small solar panel, which strangely enough was in 2008 or 9, when you were running a grid-connected solar course, and I did that and became a solar installer. We designed it in your course, and I put it up here. So it's a 1.4 panels to 1.2 inverter system, and that produces for my house pretty much exactly the same amount of electricity as I use per year.
Wow, a 1.2 kilowatt system. Is that what you said?
Yes.
Wow.
It's a 1.2 and 4 set of panels.
Yeah. So given that the average system size is well over 5 kilowatts these days, it's trending, 6.6 kilowatts being a very popular number because of rebate structures. It's practicable to produce sufficient energy or clean energy to run an EV for typical city use.
Yes. And calculations of 4 to 5 kilowatt hours of them is enough to run an efficient house and an EV for 10 per year.
Now, we've got a question here. I have no idea what this is, but the question is from Stuart. What do you think of the Aptera Never Charge concept? Have you heard of it?
That's There are some cars that are being put out. I can't remember one of them where they cover the car all in solar panels and trying to make it as light as it. And I keep referring back to the idea that we're third rock from the sun, so we have third rock from the sun issues. We just don't get enough energy per square metre for that to work. For the car, you would, if you had the car parked in the sun and oriented in the right direction on the number of square metres that you could get on the car that you're facing the sun for the day, get 7 to 12 kilometres of charge a day. And personally, if that's in which case, may as well not have a car and buy an electric bicycle.
Yeah. I think I've done the same sums. I'd be towing a trailer with solar panels on it to get a decent range, or at least parking it with a lot of solar panels. I also have the great pleasure of discovering that living on a mountain is a real asset when it comes to going downhill first thing in the morning.
Or else you won't get the benefit. Yeah. All that free energy. My claim to fame was when I did a drive around Victoria when Scott Morrison said, EVs will ruin your long weekend. So I went, challenge accepted. I shall drive around Victoria in 7 days, 2,500 kilometres later, and no DC fast charging in Victoria then. So I was just charging at caravan parks every night, comfortably got up to full charge next day. And I drove to Benzo the first day, over Mount Hotham to, the next day, and I got to the top at Mount Hotham. It was etc. And it was hammering a lot of kilowatt hours per 100 kilometres for that trip. So I got to the top, and according to my range estimate, there wasn't about 20 or 30 k's short of my destination. And I went, yeah, should be right. I'm an EV. I recharge, I refuel on the way down. By the time I got to the bottom, I was 50 k's further range than I needed.
Yep.
So yeah, suck on that. My car refuels as it goes downhill.
Well, my experience is somewhat similar to yours in that we live on top of a mountain that's 700 metres above sea level, and the nearest town is at 160 metres above sea level, which is about 20 kilometres away. So effectively, I'm going downhill almost the whole way. It means I end up with about 1% more charge than I started with. So it's a net gain going downhill, and it's about 6% loss going back home again. So of course it is the home run I really only have to consider about.
Yeah, so I wouldn't be at night. I wouldn't be charging more than 90% in that case to give yourself. Otherwise, the regenerative brake falls off when you hit 100% because there's just no more room to recharge, which is a bit of a loss if you're going all the way downhill.
Yeah, so I took your advice on that matter too, because initially it was about, there's still remnants of range anxiety even when you've got 500 kilometre range in a vehicle. And so I just set it to 100% charge, and I charge it 100% and go down the hill, and I got no regenerative braking, which actually, if you've never experienced it, is a joy. Like, you don't have to put your foot on the pedal at all. I put it on level 2 and just coast the whole way down the mountain. I don't even have to touch a brake. So it makes for more relaxing driving. There's pedals too you can use to operate the severity of the regenerative braking. That was great, but it didn't work because I had the batteries at 100% and there was nowhere for that braking energy to go. So learnt that lesson. But I think there's another reason, and it's probably flagged by Bradley as well, which is in terms of charging a lithium-ion battery, you don't really want to charge it to 100% every time and leave it 100%.
Yeah, I charge mine to 80% if I'm running around town, at just 70 to 80%, all through the COVID restrictions. I was only charging at 70%, and that was quite easy. But normally it's 80 or not. Generally, I'll run it up to 80% only. It's only if I'm going interstate or up country, I'll run it up to 100 the night before, and then when I'm there, I'll leave it at 80 again, and then just charge it to 100 before I come home.
Okay, we've got a couple more questions here. You may not know this one, but Vasuki asks, when is the Wuling Mini coming to America?
I have no idea what that is. I'll take that question on advisement and look it up myself.
Wuling Mini. And Louis asks, hi Louis, it's good to see you there. Do you think hydrogen will affect the EV market?
I'll do a quick share screen and let this particular one talk for itself. It's probably the easiest way to do it. There we go. And let's see if I can do the share screen. Just talk amongst yourselves on the web there for a moment, and here we go, and I'll make it full size. Can you see that?
Yeah, that's perfect.
Can you hear me?
Yep.
Good. Yes. So if we start off with 100 kilowatt hours of renewable AC electricity, and if you go to your right, you go to charging your full battery EV, say 90% of efficiency of your grid transmission, so you get 90 kilowatt hours to your power point. In the car, it'll do AC to DC conversion, so you end up with about 77 kilowatt hours useful. And then the BEV is about 90% efficient. So you get 69 kilowatt hours of movement out of your original 100 kilowatt hours of renewable AC electricity. On the other hand, if you go down the other side of transmit the electricity to the electrolysis plant, which is only 75% efficient, then you liquefy it and send it off in a transporter, you end up with various efficiencies, including the very poor efficiency in a fuel cell, which converts the hydrogen back to electricity. And you end up with 19 kilowatt hours of energy. So you've got 20, 40, 60, 3 to 4 times as much energy to move the car the same distance with a fuel cell as you would have with a full battery EV. So the hydrogen economy, as far as I'm concerned, at least for passenger cars, it just isn't there.
Is it giving some advantages, though, in terms of range? Is that a consideration?
Not really. Do you need any more than that range? And second, you have to find a hydrogen refueling station, of which I think there's now 2 in Australia. So that's a little tricky to find one. And you would have to pay the costs in per distance travel would be 3 to 4 times the cost of running an EV, let alone all of the transportation costs and everything else, and building hydrogen fuel stations, which are very expensive to build, versus just plugging into a power point at the worst, or putting in, say, $1,000 EVSE at home. So it's only charge on the road, so you don't have to. You might save a couple of minutes, especially with a new generation of full battery EVs. That speed of refueling advantages hydrogen has of like a petrol pump. So at the moment it's about 25 to 35, 40 minutes to do a full charge in an EV. So with the Kona, you'll get to 80% in about 35 minutes, unless you're from zero. So it's about 45 from zero. And with a hydrogen, it might take 5 minutes. But you're only doing that every 2 to 3 hours when you stop at a roadhouse, which case you're going to the toilet, having a cup of coffee, a quick walk around. So it doesn't actually slow you down for the normal stopping. And all the rest of the time, I say take 20 seconds to refuel, because I come home, 10 seconds to plug in, walk out the next morning, 10 seconds to unplug.
Yeah.
So all of that 5 minutes that you might be saving on the highway for that 1 or 2 or 3 trips a year interstate, you've lost by having to find the hydrogen refueling station and drive to Sydney or Altona to get there and then get back, and all the other 5 minutes time to refuel plus finding the place in the first place, pay your money and go away. It's just, it doesn't add up.
And you've still got the Hindenburg problem.
Yes.
Or the perception.
One hydrogen refueling station in Europe blew up.
Oh.
And basically shattered car windows and things and windows about 100 metres or more around. And it was a small hydrogen refueling station. So, yeah, they can blow up.
Okay, we've got a few more comments and questions here. So this one's from Tradie Trev. G'day, Tradie Trev. Do you think EV conversions will be a thing if government allows for tax rebates?
That goes back to my original comment about it costs to do a really good EV conversion. You're looking at paying someone else around $60,000 versus buying an EV, which the MGZS EV starts at $45,000 on the road roughly. The run-out Renault Zoes were about $37,000, and the second-hand Konas and things, you're looking at probably high $50,000. So all of those are cheaper than the conversion costs. If you're doing a conversion of a classic car, that's very different, and the economics don't come into play in some ways. It's a very specialist car. The issue at the moment is we just don't have enough EVs in various segments of the market. So there's no utes, vans. Also, a number of vans, there's no utes yet. There are several utes coming this year. There may be up to 5. Rivian RT1, if it's worth having a look on the web about that, is a really brilliant ute that's coming out of America, and they're going to be building an SUV style boxy, like a Troopy type one as well. not long thereafter. But they're at top end. They're doing what Tesla did. They're building a top end first and then slowly coming down. GM are starting to build. They're releasing the Hummer brand as a full EV range. And they'll be utes and SUVs. So wait another couple of years, there will be a whole lot more niche model segments being available. So conversions don't come up with as good a car as a mass manufacturer one. They don't have the support, so not many people know how to work on them. And it's just a matter of waiting a couple of years. The key issue with price, because at the moment that's probably the biggest thing putting people off, is around 2024 will be the rough number for meeting the price parity point with their equivalent internal combustion engine car. And from 2024 to 2028, various segments will tip over the line on price parity. So by 2028, they'll have all reached that, and the ones that got there first in 2024 will be cheaper, because ultimately an EV is cheaper to build than a petrol car.
Yeah, there's so few moving parts, isn't there? Hey, there's a comment here which is a rather good one from Nobody Famous. You only need a battery range that's bigger than your bladder range. I love it.
Absolutely perfect. In this case, by
Now, here's a question which I'm just wondering if it's the wrong way round. Would you advise car-to-home charging when you have a solar PV system off-grid at home? That sounds like car has the energy and you're putting it into your home.
So it's vehicles. There's several acronyms I'll probably throw in, so I'll define them to start with. V2H and V2G. V2H is vehicle to home. V2G is vehicle to grid. So we're talking in this case vehicle to home because they're off grid. At the moment, the CHAdeMO, which is the old DC fast charge system, does do it in limited markets where it's allowed to do so. In Australia, it's not yet allowed to be installed. So even though it's available in Japan, you can't still do it. There are a number of trials. ACT is running 50 cars at the moment with the CHAdeMO system. But again, only Nissan use that system now, and they're dropping it outside of Japan with their next EV range. So the CCS system, the combined charging system, DC charging system, is moving to incorporate vehicle to home, vehicle to grid capacity. And they say roughly by 2025 or a little earlier, it'll have it. So that will be available if you want it by around 2025. If you have a Nissan Leaf, you'll be probably able to install that starting maybe next year. There are some systems about to be released, and maybe even later this year, in 2021.
Now, vehicle to home as opposed to vehicle to grid, what's the difference?
Vehicle to home is behind the meter. Vehicle to grid is actually feeding into the grid like a Grid Connect solar system. So it becomes a grid stability system.
Right. Now, with vehicle to home, are you paralleling with the grid at the same time?
Generally speaking, you would have the other issue with vehicle to home, vehicle to grid is a different. You have to rewire the switchboard basically to have circuits that can stay on when the grid falls off the system. Just like Grid Connect solar systems, they turn off if the grid goes off. And that was always many people early in the piece didn't understand them. They said, why is my house being turned off and the grid went down? I have a solar system. And that's because the lines don't like getting fried by people's solar systems still feeding the grid when they've turned it off at the transformer. So they automatically sense the grid's there or not and turn off if it's not. Vehicle to grid systems would have to do the same thing. So unless you rewire the system that have like a UPS or a standalone little separate circuits, which means you'd have to rewire the house and rewire the switchboard to do so, your system would also turn off if it was grid connected. That would be the vehicle to grid stuff. Vehicle to home would be having a sensing system that would disconnect the grid if the grid dropped off, and it would stay on the car.
So effectively your car becomes a standalone power system when the grid fails?
Yes, but it's the one that's least optimised for the system, unlike your proper home standalone systems that will be installed and that work 24/7 to soak up your solar things when the car's not there, or you're away on the weekend and the grid fails and your grid goes off anyway because the car's not there. So, and the other thing with vehicle to grid systems is they do rely on you coming home, and every time you leave or come home, you plug or unplug the car, which, given as you would have found already, you only charge the car maybe once a week, or in COVID times once a month, in which case it's taking away a lot of the fun of an EV if you have to unplug it, replug it 4 or 5 times, 6 times a day.
I'm still in the habit of coming home and plugging in. You never know when you get the call to drive to Mildura for no good reason. So
In
we've got
which case,
a question here from David. Sorry to interrupt you. David says, often wonder about the potential of EV to grid. So this is E to G, or at least using a small percentage of your EV power, battery power to power your home, i.e. charging at work during the day and then running your part of your home off your EV. What do you think about that premise?
people will use it for that, but sort of a niche usage rather than a major usage. Fleet owners and utilities will love vehicle to grid because a fleet that might have 20, 30, 50 EVs, a percentage of them will always be plugged in, which means that they can be offered a really good tariff from the grid supply or the supply authority because they can provide grid stability in times of peak loads and demands. So they can offer them a cheap electricity tariff. And so fleets will love it and utilities will love it because it provides that extra support. If everybody's air conditioner suddenly turns on, those big fleets will power in for half an hour as the grid catches up, or people turn a few air conditioners off again. But for home use, it'll be a niche. People will use it. People will have a very good need for it in certain circumstances, but I can't see it becoming a major player in the home market. That's my personal opinion. But,
Right.
I may be proved wrong.
Well, let's go from the sublime to the ridiculous. Louis, I like this one, Louis. Just thought, because the car is moving, can we have a wind turbine to help charge while driving? Thinking outside the box may be a funny question, or would it be too noisy?
You'll be actually using more energy to tow the wind turbine through the wind than if you just took it off and had a nice streamlined car, because you've got so many inefficiencies. It's yes, the universe doesn't work that way. There's no such thing as perpetual motion. You
Actually,
can't get more energy out than you put into it.
a friend got accused of doing this because he was testing some wind turbines, small domestic turbines, and he wanted to test them by attaching it to the back of his ute on a small, short tower and driving around the streets of Brisbane at a constant speed and seeing what the output was. He got pulled over by the police, and they thought he had a wind-powered car.
Well, this is Joker Jockey territory where he advertised and got conned by the water-powered car at one stage many years ago. He launched a water-powered car. It was a complete con.
All right, hang on. Gee, it's coming. The questions and comments are coming in fast. Here's one. Don't know what this is. V2X will be available in the new Hyundai range, I believe. Whatever V2X is.
Their CCS system, so that is coming in, but not this year. CCS, the roadmap put out by the CHARID, which is the group that actually oversee CCS protocols, say 2023 for vehicle to home and about 2024-5 for vehicle to grid. So there's timelines. It's looking like they'll be earlier than that, but that is the actual published timeline from the people that control the standards. And it's a lot to do with the grids themselves and them coming up with communications protocols.
So V2X just means all the possible permutations.
Yeah. Okay, so V2 home will come first and then vehicle to grid. So V2X covers sort of vehicle to building for apartment blocks, vehicle to home itself, vehicle to grid. So you just say V to something, X, meaning something.
Here's another one from Nobody Famous. Can an EV charger be legally connected as a controlled load? Now, before you answer it, can we just clear up this thing about EV chargers? People often refer to the thing on the wall in their home as the EV charger, but it's not really, is it?
No. Then when it comes to AC charging at home, it is nothing more than an automatic power point. So it talks to the car, and the charger, which is the rectifier to go from AC to DC, is built into the car, and that's why they're at lower levels, because they're nice and small and they can build them in the car and they're quite cheap, and you don't need anything more than about 7 kilowatt chargers, because the house can't deliver more than 32 amps to the car without starting to compromise the house. So that's the charger on the AC side is actually in the car, and it's just an automatic power point. Basically, you plug the lead into the car says, "Hi, I'm a car, I want some charge." The wall box says, "Hi, I'm a EVSE, electrical vehicle supply equipment. I can feed you if you want it. When do you want it?" And the car says, "Now or this evening." And it says, "How much do you want?" And it says, "What have you got?" And the charge or the EVSE will tell it, 3.6 kilowatts, 7 kilowatts, whatever. If it's a solar connected one like the Zappi, it will actually say ramp it up and down according to the amount of solar output. So it will actually ramp the rate of charge to the car. But the AC power to the car, DC conversion inside. The Highway ones are true chargers because the charger is built into the box. They're enormous. They're liquid cooled or cooling of some sort, and they do up to 350 kilowatts,
Whoa.
which the new range Teslas currently do up to the bigger battery ones do up to 250 kilowatt charging, so they can be fully charged in 20 minutes.
Wow.
So I'm saying that advantage even over hydrogen is already evaporating with the next generation. And the next generation will be 350 kilowatts. Port Taycan will be there soon, and that will mean it'll be 10, 15 minutes for a full charge on the highway. You barely get time to drink a hot cup of coffee in that.
Yeah, yeah.
But they're a true charger. They actually do the AC to DC in the box, so they're a true charger, and it's DC fed to the car.
Gotcha.
So anyway, before we go to controlled load, that's yes, in Queensland, in fact, you can't put in the Ergon and Energex areas, you can't put an EV outlet in higher than 20 amps unless it is controlled load. So then you can put the full 7 or 11, whatever kilowatts, 22 kilowatts.
Maybe explain what a controlled load is.
You go for it.
No.
Or you explain it, or shall I?
Well, you do it.
Okay, a controlled load is like your old off-peak hot water service. It has the old ways it used to be done by times, 11 p.m. to 7 a.m. as an example, or on weekends. Now we have the off-peak rates. Sometimes they used to do it in New South Wales. They'd actually send a pulsed signal down the power lines, and because the load was not high enough and they didn't want to turn the coal plants down, so they'd send a signal out and say, turn on your hot water services at midday because we've got too much power. So people could get a free top-up with or not free, but a cheap top-up. So it's controlled load. It's either controlled by a time clock or controlled by signalling to charge or use at peak times of low demand. And that was their purpose. So controlled load means that it's separate to the normal 24/7 usage like a fridge does or a washing machine or whatever you do during the day. Turn on your big screen TV. So they're controlled load and they are a separate tariff and a different electricity charge. In the Ergon Energy Queensland, that is, you may have the full EV charging regime so long as it is a controlled load and not otherwise.
Yeah, I guess the key word, it's controlled by the utility. They determine when that circuit's available. Yeah, so it's to their benefit. Okay, you've got Bradley just pointing out something here, that charging at work during the day when there is excess PV on the grid rather than relying on home batteries for night charging could be part of an employment perks, i.e. free car charging at work.
And then you get into fringe benefits tax. It could get horribly complicated, but yes, it certainly is. If you recharge, work for free charging, come home and run your house at night, you could have free electricity permanently. All you're doing is paying the service charge. And we've got solar panels to cover the service charge. Well, I'm still on the old premium feed-in tariff. I haven't paid an electricity bill in 12 years, apart from once when I got a bit carried away with the Kona and started charging it during the day. I very rapidly learned that was a dumb thing to do. So I actually had a $35 electricity bill for the first time in 12 years.
Yeah, I mean, I guess managing the national grid in a way is more an IT issue around scheduling, controls, etc. And the more controlled loads and controlled generation that you can stick in there, the better it can be managed, rather than just relying on a phone call to a smelter. Can you turn off some of your pots, please?
That's a much better idea. So controlled loads and EVs are marriage made in heaven in some ways. Unlike air conditioners, when everyone comes home and they're hot, they want the air conditioner on. I literally all try to charge my car overnight in the low periods. A, because it is cheaper, but B, I'm not loading up the grid. So I wouldn't come home on a hot day and plug the car straight in unless I was really desperate, which I haven't ever had to do yet. So it's purely a matter of I charge when the grid is at its lowest usage, or once the premium feed-in tariff goes away, then I'll start I'll put in a much bigger solar system, and then I'll just start using my solar panels. So again, I won't be running off the grid, so I'll be even happier with that.
So are you saying, did I hear this right, that you'd rather not charge your car when it's hot? Is that for the car's benefit or for the grid's benefit?
For the grid's benefit mainly, because obviously everyone's doing their air conditioners on, so I don't need to add to the grief. So I deliberately wouldn't charge it on a hot afternoon. But it's also better for the battery, like any chemical reaction. It's just batteries don't like being charged when they're hot. They will actually throttle themselves back in charging. There's a thing called, was it ChargeGate? For Nissan's, when they first released the 40 kilowatt hour battery, and the Leafs, the new generation Leaf, and You could fast charge it once on the highway, and the next time you chucked it into a fast charge, if you've been driving and that charges to the next, say going interstate, it would charge at a significantly lower DC charging rate because the battery was already quite warm from the first charge and from the driving. And it went, no, I'm too close to my threshold temperature. We'll just ramp it down and keep things a little bit more under control. So it's kind of the battery not to charge it in a hot day in the hot sun. Certainly if it's a Nissan. Most cars have an active cooling system. Tesla has a liquid cooling system to keep the things pretty tightly controlled, and most other cars are the same. So
speaking of cooling, this was a little discovery for me, was using the app. I can tell my car to cool itself before I go to it. It's not like having to run an engine. It just electrically runs its air conditioner. So I go 10 minutes before I get in it, I just press, run the cooling. And so on a hot day like today, I step into a cool car and slide off.
Yes. Many EVs now, and probably all of them within a year or two, will have that function.
Yeah, it's pretty cool.
Purely, you're not running the motor, you're just turning the air conditioner on, and given it's a reverse cycle air conditioner with a good coefficient of performance, it's just pumping the heat from inside the car out rather than creating heat. So it does a really good job. Unlike the heater in our Konas, though, in cool climates they put the reverse cycle air conditioning in. In warmer climates like us, they put in a resistive element like a toaster, which is just you are creating the heat. So it's actually very inefficient in terms of. So you'll notice when you turn the heater on in the Kona, the range drops by about 10% or more. Whereas if you turn the air conditioner on, it doesn't drop very much because it's a heat shifter, heat pump.
Yeah, so right. I was wondering about that because I did notice that it was a much less efficient with heating than cooling. So, yeah, it's not reverse cycle. Just looking at the questions here. This is from Louis again. Hi, thanks, Louis. We do have time of use tariffs where everything is on a cheaper rate, say weekends, and say at 11 p.m. to 7 a.m. So would that be something that you could schedule with your vehicle or with your EVSE?
Both. Some EVSEs you can schedule it with. I have a very dumb one, so it doesn't have that option. So others do, and the cars pretty much all do it. So I'm actually charging my partner's Renault Zoe at the moment. In fact, it's probably already charged, but that's I'm charging it in the off-peak rate on the weekend for that reason. So it's just time of use tariff. So it's a weekend. There's no industry as such running heavily, so it's a low period, although it's probably a bit warmer. So I charged it up this morning before the heat of the day, so people will be busily running their air conditioners now.
So these are already great examples of how the cleanness and the merit of your charging sources can be varied all the time with an EV. As opposed to petrol, it's always coming from the service station. It's always got the same kind of environmental impact. You've got no choice over the matter other than price.
Yeah, and the other deal is we're not subject to the old petrol price cycle.
Yep.
We can plug it in at night or during the day. We can choose what our particular price cycle is. So we can plug in overnight. We can plug into our most green source during the day if we have a big solar system, or we're subscribing to green energy. So if you do your own solar system, subscribe to green energy and charge overnight, that's probably the best for you and the grid.
Actually, my guest last week, Sam Frost, it was all about crypto mining last week, but he uses a retailer who lets you access wholesale prices. I think they're called Amber Electric, and so he basically operates his mining adventure based on price signals in very short periods, like 30 minutes. You could do the same with smart retailers who provide that ability so that you could choose when the cheapest form of electricity is available. It doesn't have to be just a scheduled time of use, weekends or middle of the night.
Yeah, I must admit it's probably getting too much of my little brain. I know the times, I can plug it in then and I can adjust accordingly. Some people enjoy electricity too much.
It's your level of geekness that matters, really. Yeah. Now, one of the questions I had in my list here was to do with the economics of electric vehicles, and people often ask me, what's it cost to run? And you've already mentioned that the service fees are so small, $165 a year or something to get it serviced. What about the economics in terms of running it for, if you're buying electricity from the grid, though there is price variation, some, ballpark figures? Is it cheaper than a petrol car?
Oh, yes, it is much cheaper. I'm just trying to find if I have that slide readily available. I don't think I have. It's at a different slide. And because I do have the emergency computer changed just before we started. It's not on this computer. But the economics of it are, if you're charging an ordinary day rate, it's about a third the price, not a third cheaper, a third of the price of petrol for the same distance. If you're charging off-peak, it's about a quarter. And if you're charging off your own solar, maybe an eighth, because you're paying, I think, amortize the cost of a solar system over the lifetime. It's about 6 cents a kilowatt hour. I think that's a rough number. So it works out, about an eighth of the price.
So worst, a third, best, an eighth, and if you're off-grid, possibly even better. So, yeah, no service fees.
Off-grid is about an eighth because it's your amortizing of the solar panels.
Probably
a little
true.
more than that. That's where that 6 cents comes from for a grid connect. If the grid connect and battery, maybe 10 cents. So you're probably still a fifth. It's very, very rubber numbers, by the way, but that's giving you some rough examples. So even if they put the EV tax on at $200 a year, it's still way cheaper. But it's just the signal, the psychological signal that they're sending to people about we're taxing you and making EVs. We don't really support them. I think that's what the governments are saying by putting those or floating those types of taxes. At this stage, it is really to tax something that is green, meets our emissions protocol, or helps us meet our emissions protocol for Paris agreements. Why would you try and say, no, we don't really want them and we'll try and make some more money out of them? So we're just discouraging it rather than making it really positive. And actually, in other countries, they give you tax incentives to buy an EV. They give you, in Norway, for instance, which is now past 2/3 of all new car sales are EV, battery EV or plug-in hybrid. 50% of new car sales are just fewer battery electric vehicles now. And they give you massive discounts off sales tax, all sorts of excises and everything else are reduced for EVs because they say we want you to move to a clean, green source of energy for your cars. Deliberate. And a lot of other countries have various mixes of that version. Even England, the home of, I'm trying to think of polite words, they're called their relatively far-right government, are very much in tune with changing over to renewable energy, all sorts of policies that support EVs.
Bradley's asked a question here. Any early indications of resale value of second-hand EVs?
Yes, they're holding up quite well. Tesla's buy for much less than what they sold for new, even however old they are. Nissan Leafs have not just bottomed out, they've started going up again because there's the demand and supply. There's a small supply of them because EVs have been very slow trickling into Australia. There are some private imports, small group buys coming in from Japan to add to that. So BMW i3s went upping in price again. So they're actually holding up quite well, even the older ones. So you can pick up a reasonable iMIV or early Leaf for 10 to 14,000. The only deal with that is you would need, with the Leafs in particular, to factor in putting in a new battery in it. Leaf to put a new battery in for about 10 years.
Right. So I'm just thinking on my feet here, is it quite viable to replace the battery?
In Nissan Leafs, again, the price of batteries is the thing that is holding back the price fall of EVs versus petrol. And 2024 to 2020, they start and all cross the threshold of price parity with petrol, and that is to do, they say $100 US per kilowatt hour of battery is the threshold. So once they cross that, and they're crossing it now already, so when they cross that point, that's when that price parity point happens. So they're certainly getting quite cheap with batteries.
Right. Wow. Okay. Well, think of an internal combustion engine. There's so much to repair as time goes by. All those moving parts, those thousands of moving parts. An electric vehicle, you've got an electric motor, a steering column, wheels, brakes. There's hardly anything.
Sadly, it's about a third less workforce needed to build an EV compared to a petrol car. That's the motor and gearboxes, exhaust system, fuel tank is all gone.
Yep. Great. Okay. So, what can an EV do that an internal combustion engine vehicle can't do?
Very smooth and quiet. Won't
Okay.
kill you in the garage if you leave the car running. Yeah, the only minor detail there is I'll occasionally get out of the car and it starts beeping at me as I walk away, and I go, "Oh, I forgot to turn it off, didn't I?" It doesn't. You don't hear it running like a petrol car would. So that's probably one of the things. It is fairly easy to wander off and leave it running. You may have already done that already. It just goes beep beep, and you go, yes, wander back. But yeah, they're very good torque, very good pulling power. So even though not many of them are rated for towing, they are actually a better tow car than a petrol car, and probably up around what a diesel would be with a very low end torque, things like that. Sadly, they're just not getting around to rating them. So the Konas, even though the petrol one has a good tow rating, they keep saying they will rate it for the Kona EV for towing. And between you, me, and no one was just telling you and no one else, the petrol Kona tow bar bolts straight on the back of the electric tow Kona. So there is one on mine, and I think half the Kona owners I know have done it. And they tow really well because of that really good torque. It's just you wouldn't heavily load it at the moment because they're obviously not fine-tuned for it, but it's purely a matter of they will tow quite. Any electric car will tow quite well. The Rivian, for instance, will have I can't remember, 2.5 ton or 3 ton towing capacity. The Tesla Model X has a 2.5 ton, I think. A number of cars. Whilst I'm babbling, I could probably pull up my own. I have. I might even pull up the link in a minute. The Australian Electric Vehicle Association. I run the fact sheets, and I actually have one page. Unfortunately, because I've swapped computers, I can't pull it up for everybody else, but I'll pull it up and read it off for you. So just flick through the website, and I shall flick through the fact sheets. Actually, I could do it on the share screen, I suppose, and just go straight to the AVA.
While you're looking it up, I'd just like to make a point. So people often say to me, is an electric car, those performance heads, is it better than a performance internal combustion engine? And my standard response is it's an unfair comparison. It is, almost always better because of the torque at minimum revs. It's the unbelievable thing. An electric motor has maximum torque at minimum revs, which is almost the opposite of an internal combustion engine. You've got to spool it up to get the power and the torque. So, the experience is at any highway speed, you put your foot down and you're thrown back into your seat. So it's just amazing experience. Traction's probably the only thing you have to worry about.
Yes, and the earlier Konas didn't come with as good a tyres as they currently come with. So it's very easy to break traction, even in normal setting in the Kona, let alone the sports setting. But if you watched Craig Rucastle's documentary on the climate, I can't remember the one recently, he did a Tesla performance versus a HSV Commodore. It beat it hands down in a drag race. The HSV Commodore driver was just, what?
Actually, that's the exact one that someone pointed out. They said, was that true? Were they just, making a point that's, stretching the truth? I said, no, that's totally true. Do you remember that when our illustrious Prime Minister said, you're not going to be able to tow a boat, and then Simon Hackett went and towed his small aeroplane, and then someone else got a Tesla and towed a Qantas 737. So,
yeah, the Tesla Model X, I'll just pull it up here, has a 2.25 ton tow rating of a brake trailer. The Tesla Model 3 is a 910 kilo. The BMW X5, which is a plug-in hybrid, but that's 2.7 tons. The Jaguar I-Pace is a 750 kilo. So they're slowly starting to rate them for towing. It's just, for whatever reason, they're just a bit sluggish getting around to it.
Cool. All right. Well, look, we're coming to the top of the hour. In fact, we just overshot a little bit, so I'm going to start winding up. But I've still got a few more questions in the list that I wanted to go through. How long will batteries last in an electric vehicle?
I think I actually answered that very early at the start. In an electric vehicle, 8 to 10. I sold my old 2011 Leaf. In fact, the guy, Trevor Plumridge, that bought it, and they're still running on the original battery, even though it's down to about 90 kilometre range because they're just beetling around town in them. So that's a 9-year-old battery. So it's probably another couple of years at that sort of usage comfortably. So that'll be 10, 12 years old before it gets replaced. And as I also said, with the longer range batteries, if you're losing 20 to 30% off a 500k range, 50 to 400 k's at the end of 8 years. So it's probably, some people may not replace the battery in 15 years. Some people might replace it if they're heading into state of lock in 8 years, and that battery will then be usable for standing storage for up to 20 years or 25 years of its life.
Right. So, certainly a long time. I mean, considering the length of ownership of a vehicle, probably is similar to that. Yeah. Look, I'm a bit keen on cross-country skiing, and I know that lithium-ion batteries aren't so fond of being charged when they're cold. Does that mean I can't take my EV up to the snow?
Back to my comment on active cooling systems, they're also active heating systems. So a Tesla on the highway will, if you're told that you're going to be charging up at a supercharger, which is their DC system, will actually start bring its temperature down a bit more to allow for the extra heat that's being pumped in for the DC charging. And so it's an active cooling system, so they will cool the battery or warm the battery as required. So in cold climates, cars, some EVs are actually fitted with battery heaters as well. But it's like our particular cars. Ours may not have battery heating in it, but they certainly are maintaining the temperature. So if you're just gently charging it overnight, say in a 15-hour power point, 3.6 kilowatts, it would warm the battery enough just in the charging process to even warm it charge it in the snow.
Right. So to some extent, the extremities of cold and whether you have active heating or cooling will determine what those limits are. So, yeah, great.
It's the same with driving a car up to a high altitude. You start getting limits on how much oxygen the car can actually get in, and it becomes running too rich or loses power. So it's horses for courses. Diesel cars have different requirements for the way you drive them.
Cool. Well, my last question for today actually is what we started off on this one, and maybe there's a bit more to say, which is really kind of the political aspect. So why do you think state and federal governments seem so hostile towards EVs?
Federally, I can sort of see that during the last federal election, they had a road away from Damascus moment because their eyes were suddenly open to realise that supporting EVs was effectively supporting a climate change policy, and therefore they went from fairly neutral to semi-positive about EVs to, oh no, you can't possibly have them because they're, to say that would mean that we might be admitting that there is a climate change problem. So I think federally and liberal-wise, it's become caught up in the climate wars in that case. And the state governments, I have no idea, especially when it's coming up with trying to impose a equivalent to the fuel excise state-wise when it's a federal excise. So I'm baffled. I still don't understand that one.
Maybe they're trying to make a grab for the equivalent excise at a state level that they're losing. Well, as the federal government's losing, they're trying to use it as a leverage to gain it.
It could be that if federally they collect it and distribute it back to the states, the federal may say, oh no, we're not collecting it anymore, therefore you don't get it. So maybe the states are preemptively trying to claw it back, but it seems a pretty dumb way to do it.
I mean, to be the devil's advocate, isn't it the fuel excise to help pay for the wear and tear on the roads that vehicles do?
Yes, except that it generally isn't. It's just consolidated revenue. And, there's some money spent on roads, but it's not equivalent to taxes, and most of it just goes in consolidated revenue for everything else, which I don't mind. I don't really have a problem with it, and AEVA, as general, has no problem with some sort of road user charge. Just make it fair. If you're going to do it, put it on all vehicles, and therefore the petrol cars are paying that as part of their contribution to environmental damage and climate change. So it would be a better way to do it, put it on all cars, and then say, okay, if you get away from a petrol car, you actually pay less, but you're still end up paying what you used to pay. And we're actually trying to discourage fossil fuel car use and increase electric, renewable energy powered car use.
It's been proposed that it should be based on weight and distance. So those are the things that affect the wear and tear on our roads.
Yes. But mainly, so long as it was put on everybody and it was used as a disincentive to own petrol cars, not a currently way of putting it, a disincentive to, or at least a change in mindset of, maybe electric cars are being discouraged, so maybe we won't consider them. So rather than put them in a positive light, it's sort of throwing a negative light on EVs, but it's just dumb.
Yeah.
How many different ways I say that's just dumb? That's probably.
Well, it's been great chatting to you today, Bryce, and thanks for getting through the technical problems at the beginning. That's the internet. That's
IT frustrations.
yeah.
In about 30 seconds to the start.
And thanks to everyone who chimed in the comments. That was just great. Feel free to give us a thumbs up. That's always good for the channel. And if you want more content like this, don't forget to subscribe from whatever media outlet you're approaching this from. But otherwise, I'll see you next week on Toolbox Tech Talk. So I'm signing out. See you, Bryce.
Yep, see you, Glenn. See you, everybody. Thanks for the good questions.
No worries. Okay, well, that's it for today. And don't forget, subscribe, thumbs up, like, all those good things. And thank you, everyone. I can see some comments coming in. That's great. Okay, we're out.